the packet to PC1. 2.100 received 1.100. When replying to the data packet, the network segment is crossed. It also looks for its gateway. It also depends on its watch. So is there a route to the 1.0 network segment in it? Because 2.100 is going to reply the data packet to 1:100. Then it has to help forward this packet. But without this route, it only has a direct connection 192.168.2.0. 1.0 is not. I should write 1 now. So say we now need to be on R2. To add an IP to it. IP route 192.168.1.0. The next hop is 12.1.1.1. Now we can take a look at local now. The next hop is 1.1.1.2. That happens to go out from the local 00 interface. Because this is its direct connection. Back on R3. R3 to check if the data can reach 1.100. Seems to be able to. The routing table of R3 has this. Because this is its direct connection. So now you can ping. We have now completed the communication. That is, they already have routes between each other. Look. I am referring to a 2.0 here. Pointing to a 1.0 here. Let's quickly talk about the next few. Intercommunication between two PCs. If now this device is 1.100. If you want to visit 3.100. First of all, this device must have a connection to 3.100. It has to have. Then it must have. It is direct. That is, we want to configure once. Configure twice. This is past data. When the data comes back, data flow goes here. It's going to reply to 100. It also needs to be configured once to go to 1.100. 3 configurations. Just finished writing here. This is direct. So in theory, we should configure 3 times. Okay. Let's configure it according to this. You see the hostname here. Don't look at the name above. First of all, we are on the device R1. I am now writing a trip to 3.0. We let 1 and 3 pass. IP route 192.168.3.0. The mask is also 3255 and a 0. Go to 12.1.1.2. This is the next hop. Similarly, we also need to configure the R2 device. 192.168.3.0. Its traffic goes to R2 here. R2 also needs to check how the data passed. Also 3255 and 10. The traffic is lost to the current device. The next hop is 23.1.1.3. Theoretically, the data is now in the past. PC1 sends data access 3.100. Find gateways across network segments. Gateway just wrote. Go to 3.100. Go to 3.0. Next hop go here. Traffic to this device. It checks how to get to 3.100. Discovery is a local direct connection. Data is coming. Terminal receives data. Discovery purpose MAC is it. The destination MAC is the MAC on the link. It must be it. Notice. Between them, they go to make ARP requests. Anyway, it's packaged. Take a look at the 3 layers. The destination IP is also it. This is indeed the data given to it. It wants to reply. Looking for a gateway across network segments. But it won't work if the flow is placed here. It's definitely not working now. Because 1.100 traffic comes back to this device. It will be lost. Because it doesn't. So let's test. Here on PC1. Ping 3.100. It sure doesn't work. We can write a route to make it pass. We write a route to 192.168.1.0. The next hop points to 23.1.1.2. Now the traffic can't come back. Data here. The next hop is dropped to the 01 interface of R4. Data coming. Just to configure the intercommunication between PC1 and PC2. This address has already pointed to the 1.0 network segment. So we now write it. After writing it, I can pass it now. So what is missing is actually such a return route. This is the communication between 1 and 3. At last. Let's take a quick look at the communication between R2 and R3. Now I want to communicate between the two. So on which device do I need to write several routes? Data here. This device has just been configured. Going to the 3.0 network segment. Because just now in order to let one and it communicate, data is ultimately forwarded through it. It has to know. So it has been configured with. This traffic is sent here. It will give R5. R5 direct connection will give it. Then we calculate the data reply packet. Back to the current device. 2.100 send data to it. That is the data sent to it by the 2.0 network segment. It has to reply packets. But it doesn't now. We can configure a return route on this device. So now R2 and R3 communicate. We go directly to this device to ping. Ping 192.168.3.100. It doesn't work. Let's configure. Configure an IP here. For example, IP route 192.168.2.0. Then the mask. The next hop is 23.1.1.2. After we have configured, let's go back to this device. Ping 3.100. They go through. For static routing, you may find it complicated. But it's actually not that hard. Just configure a lot of things. Let's sum it up. In order to allow devices to communicate with each other, you will find R3 acts as a gateway for PC1. If PC1 wants to communicate with PC2 PC3, it must have 2.0 and 3.0 network segments. That for this device. It must have 1.0 and 3.0 network segments. For this device. It must have 1.0 and 2.0 network segments. Therefore, each device must be configured. Other network segments that are not connected to itself. So you will find, for the overall static routing configuration, it's just 3 devices. Under 3 devices, there is only one network segment between each. Everyone feels so exhausted. So what about more routers in the future? Will routers have more network segments in the future? In the future, the following terminals may need to be divided into different network segments. Connected to the router. Use static routing. It is actually troublesome to configure. Okay. We'll stop here. Then we also hope that students can follow us. We are ThinkMo Education. I'm Grolin Annesley from ThinkMo. I hope today's content is helpful to you. See you next class.